Hi everyone and welcome to this week's Lecture Tuesday. I'm Ivona Ivkovic-Kihic, Research Project Coordinator at the Center for Compressor Technology at City St. George's University of London. I have a background in computer science with extensive experience in development of virtual and augmented reality. Therefore, today we will be talking about applications of VR and AR for compressors. First of all, let's make sure we're all familiar with the terms we will be using today, and especially the difference between virtual and augmented reality. Virtual reality is a computer simulated environment, where the user is placed inside of an environment. It is created by a combination of different digital objects, like 3D models, 360 videos, images, audio, and visual effects. The user can generally interact with the environment in some way, whether by clicking on some object, moving things around, walking, etc. The user is immersed into the environment to some extent, depending on the application and execution of the app. Usually, VR requires specialized hardware that can include VR headsets and controllers, haptic devices like gloves, or full body suit. On the other hand, augmented reality is a real-life environment that is enhanced by computer-generated content. It overlays digital elements over the physical world. These elements can be any digital objects such as text, images, and 3D models. Even though specialized augmented reality glasses exist and are being used for more advanced applications, AR can be shown on phones and tablets as well. So, how can VR and AR be used in engineering and especially in compressor technology? Let's look into some of the possibilities. First of all, design and prototyping can be done in the virtual reality environment. Engineers can create virtual 3D models of compressors and test design aspects like airflow, mechanical stress, and efficiency without building the actual physical prototype. Next, more immersive remote control and collaborations can be enabled in virtual reality environment. Let's imagine sitting in our office or home office and controlling the compressor that is operational in some lab. But with VR, we can step into that lab, of course virtually, tune the valves or inspect the machine, as if we were there. Next application is for training and simulation. With a well-prepared virtual reality environment, we can do trainings and simulations of machine operation, assembly and disassembly, or maintenance. VR allows trainings and simulations in safe, risk-free environment, and this can be very beneficial for educational purposes. Augmented reality can be used for maintenance and repairs. For example, if an engineer scans the machine with a tablet, AR can plot all the information about the machine and then highlight on a real-world image the part that needs to be replaced or fixed. Similar for inspections and monitoring, where VR can make these operations much more user-friendly and intuitive. AR and VR are also great tools for demonstrations. For example, showcasing the work and efficiency of the machine to a client in virtual reality. This way of demonstration can be very interesting, easier to comprehend, and therefore more appealing to the user. A lot of research and development has already been done in the field of applied VR and AR to compressors. So, here are some of the examples. First, here we see an operational disassembly of compressor in VR. Then, live data projections of the compressor in AR, and animation of the refrigerant flow in the compressor in AR. For more information, you will find links to these publications below. One of the questions or remarks that is unavoidable in any discussion about applied virtual or augmented realities, but it can also be done on the computer, which is true. But VR and AR also have their benefits. They can be a cost-efficient way of conducting training in a safe environment. VR simulation can train engineers on how to perform dangerous or difficult procedures such as operating heavy machinery or working with hazardous materials. VR also allows advanced visualization in 3D space and presenting information in a completely different dimension compared to desktop devices. VR can provide a true sense of depth and space, and it is a valuable tool for visualizing complex structures. This can lead to better and easier understanding. Plotting digital elements over the real world that is done by AR can make certain tasks more simple. For example, locating certain components on the machine or understanding measurements if they are shown in the strategic position. This cannot be so easily done on desktop device. VR and AR also have their challenges. First of all, VR hardware can get very expensive, and development of VR and AR applications is also costly. For compressor application, there can also be a big knowledge gaps, and understanding and accepting the new technology can be a challenge for engineers who are used to certain practice and procedures. Integration of existing systems with AR and VR can also be a big challenge and a barrier in introducing these technologies. And lastly, VR and AR, even though they've been around for a long time, are still not sufficiently developed for some applications. So to summarize today's short lecture, I can definitely say that there is a lot of potential in VR and AR and a lot of space for these applications in compressor technology. But there is still a long way before these technologies can show their full potential and start making big difference in the way compressors are designed and maintained. Thank you for listening. With that, we conclude today's short lecture. For any further discussion and questions, please get in touch.